variable geometry turbochargers are already the technology of choice for passenger car and many light to medium commercial vehicle applications around the globe. As the Euro 6 emission standard comes into effect, FPT Industrial and Honeywell have collaborated together to bring VNT duty drive technology to heavy-duty applications. Performance, fuel economy, durability, and reliability are key criteria, and the combination of the FPT Cursor engine and the Honeywell Duty Drive VNT delivers them all. The turbocharger's prime function is, of course, to boost the engine in fired mode, and the VNT feature allows the engine maker to optimize the system for specific torque, power, and fuel economy. For heavy-duty trucks, though, the control of vehicle speed during hill descent is equally important. When designed properly, the VNT can play a pivotal role here too. During fired operation, the FPT Industrial valve train operates on standard fixed timing. When braking is required, an eccentric sleeve in the rocker arm is repositioned hydraulically. This brings two small lobes on the exhaust cams into action, resulting in two extra short openings of the exhaust valves. The first opening occurs at the start of the compression stroke, where the exhaust manifold pressure is higher than the in-cylinder pressure. This causes some exhaust gas to flow back into the cylinder, which charges it with extra mass. Once the valve closes again, the engine acts as a brake during the remainder of the compression stroke. The second opening occurs around top dead center. It causes the cylinder to suddenly decompress and prevents the contents from doing any positive work on the piston during the expansion stroke. By doing this, the engine is capable of producing a braking power equivalent to around 40% of the fired power. Closing the VNT mechanism can amplify the whole effect by simultaneously boosting the engine and providing more exhaust manifold pressure. Braking power generated this way can be up to 90% of the fired power of the engine before the turbocharger reaches its speed limit. With the addition of an exhaust flap downstream of the turbine, however, the turbine outlet pressure can be controlled and the turbine expansion ratio reduced, which leads to lower turbo speed. This, in turn, allows the VNT vanes to be closed further until the turbo speed limit is reached once again. The combined system can deliver a braking power of up to 120% of the fired power of the engine. All this puts considerable stress on the system. Mechanical vibration increases strongly, and the high expansion ratio and flow creates massive turbulence that tries to excite the natural frequencies of the turbine wheel. The newly developed VNT duty drive makes no compromise, however. It is specifically designed to boost the braking power of the engine reliably over the life of a modern heavy-duty on-highway truck. VNT Duty Drive, class-leading boosting and braking for heavy-duty trucks.